coming now to a big player in the market, one of the market leader, because we are talking about a company that has exactly 50 years of experience. And of course, you can't rest on your laurels, that's for sure. You can't say that was it. So, and today it's not longer only about new machines, new process or software, it's rather the combination of the three factors that decides about success or non-success. So I'm really excited to announce the next speaker because Darren Fox from ANCA CNC Machines will present us their new product lines. And Darren, stage is yours. I'm really looking forward to his speech. Thank you.
Thank you for the introduction. As Sven mentioned, my name's Darren Fox. I'm a product manager at ANCA. And over the last few years, we had discussions around what is the perfect tool. As market demands, higher quality products at lower costs, so do tool manufacturers. So we started to talk around what is that perfect tool, and we started to look a lot closer at, the dig marks, the transitions, the micro features of the tool. So we wanted to come up with a machine that was able to grind the perfect tool and elevate tool grinding to the next level. And this is where we come up with the idea of an Ultra. So what is an Ultra? It's ANCA's new machine line that takes standard machines with the latest technologies and takes it to the next level. So our Ultra Premium range of machines can deliver high-quality cutting tools, and when I mean high-quality cutting tools, superior surface finishes from tool number 1 through to tool number 1,000 or 2,000, however large your bat size is. But achieving the perfect tool required a lot of attention to detail. So what was it that we needed to fix in our own machines to create the perfect cutting tool? There was firstly tool geometries. So we had to look at the RN34 software that we have, and we looked at ball nose cycles. We looked at new chisel edge geometries, fluting cycles. So we looked at all the software features to improve our own software to create that perfect tool. Now we released this time at Grinding Hub, which I'll talk about a little bit later on, is RN35. So we're focused on the performance and productivity improvements. Another area of what creates the perfect cutting tool for us was we had to look at the actual cutting tool, the surface quality that was required. So to do this, we had to look at the mechanical side of our machine and design a new C-axis and a few other areas of the machine. We looked at the tuning of the machine. We created new servo algorithms, which we call ANCA Machine Intelligence, which is a repetitive learning. And obviously, we looked at other parts of the grinding cycles. And lastly, but not least, did that work? We looked at the tool grinding process as well. So although we looked at the software first and the machine itself, we had to look at the process. It's not just as simple as creating a program, having the machine, and pushing the button. So it's also about the process that we follow to get that perfect tool. So we had to look at the process of measurement in machine compensation. We had to look at thermal stability of a machine. All these factors, when we come together, is what was required for ANCA to create the perfect cutting tool. But the ANCA is more than a machine, because we looked at those submicron features, even close, very close. Once again, I mentioned before the dig marks between grinding the OD of an ML to the transition where it may change to a profile or another movement in the machine. And quite often you get dig marks and waviness and variation depending on the frequency of the servo drives and motors. And this is only possible to achieve these ultra quality tools through ANCA's vertical integration. And I'll go into a little bit of what ANCA's vertical integration means and what sets it apart from our competitors. So when we look at the Ultra package is made up of many different areas. So the first part of looking at the machine was our mechanical design. So we designed a new C-axis. We found that with the Ultra package, that was an area we needed to improve. So through ANCA's vertical alignment, we created a new C-axis, which gave us a lot less bending forces. So it was a lot stiffer C-axis with a new bearing, a new motor spindle, which gave us better transitional movement around the C-axis as well. So that gave us a smoother movement of a tool. One of the big parts of the Ultra is the 1 nanometer resolution. Now, to explain 1 nanometer resolution, I'll show on the next slide, but when we talk nanometers versus a standard linear machine or all competitor machines in the market for tool and cutter grinders, 1 nanometer resolution is how we can control the machine movements to such a small detail. And this is what's required to create the perfect tool. New servo-controlled algorithms, so ANCA's machine intelligence. So within our servo drives, we have the ability to program and change the frequency and the movement of the machine. We also have MTC, a new feature that is patented in the USA and pending in other regions, but it helps keep the spindle temperature of our motors at a constant temperature. Also, we have new software that helps the geometries of the tool, Laser Ultra for in-process measurement and compensation. So if we're doing tool number 1 or tool number 2, we can automatically measure the tool without taking it out and taking it to an external measurement equipment and put the tool back in. We can measure the tool inside the machine and compensate as we go. So we can measure tool number 1, tool number 2, tool number 3, and get that perfect tool over the batch. Eye balance is very important when we grind high quality tools because we're able to balance the wheel inside the machine, so inside the grinding spindle that we're going to be using. Now, people may not think that's important, but if we do it offline, we're changing spindles. So with eye balance, we can get the RPM at the speed that we're going to be grinding, and we can position a machine where we need the most important accuracy to balance the wheel. So the balancing the wheel takes out a lot of the harmonics in the machine and controls the frequency of the grind. And of course, grinding best practices. Now, I mentioned before about the processes. So grinding best practices is to make sure the wheels are correct, to make sure the wheel conditioning is right, and I'll go into that a little bit later. So the results of the Ultra were quite, when we put all the package together, were quite outstanding. So with the high quality tools that we can do now, we can now boast, like when we're doing profiles or corner radiuses or ball nose, we can get the accuracy down to less than 2 microns of the profile. And that's only achievable by using our Laser Ultra and some of our machining processes. We've also eliminated those blends and transition marks that you would find in standard tools. We guarantee plus or minus 2.5 microns across your batch of tools. So once again, whether you're doing 1 tool or you're doing 1,000 tools, we guarantee 2.5 microns across that batch through the in-process measurement. So the Ultra now takes grinding tools to the next level. It's enabled us to now grind tools down to as low as 0.3 millimeters, so 30 micron tools, and to control those tolerances and line form accuracies over the batch. So it's quite an impressive feat, and once again, it's only possible through ANCA's vertical alignment. We look at some of the features on the tool, the surface finishes, the smoother gas faces, linear chisel cutting edges are a lot sharper, a lot more defined, line form accuracy, and that, once again, that invisible OD ball transition. So I spoke about ANCA's vertical integration. At ANCA, we do everything ourselves. We don't rely on third parties or outside suppliers. We do everything ourselves. So from the mechanical machine bases and all the axes and movements, we design and build ourselves. The polymer concrete base is unique to ANCA. This tool room software. Without the tool room software, we cannot grind the tool. At ANCA, we make the software for cutting tools. We don't have a software that's used for grinding machines or machining centres. That's all part of one. Our software is designed and optimised for cutting tools. We build our own linear motors and our own servo drives. So this gives us the ability to control what we do, not relying on a third party to supply, say, our servo drives or like a Fanuc or a Siemens drive that our competitors use. We make our own drives, so we can control what we do with them and manipulate them how we need. Moving further into the vertical alignment, as I mentioned, we design and control our servo drives and linear motors. So behind the servo drives, we're able to program 1 nanometer resolution. We have a zero following error control, so when the machine changes movement from going forward to backwards, we don't get those jerks, we don't get those stall positions or pauses in the movement. Advanced external disturbance observer. So this is really important. So if we have a vibration through the machine or an out of balance wheel or some of these external disturbances, the algorithms automatically compensate in lightning speed, nanometer speed, to compensate these disturbances. ANCA machine intelligence, once again, it's a new algorithm that's only found in the ultra machines, which helps us to react and learn as we go along. So if these disturbances continue to come, we learn and we can compensate even faster to eliminate these disturbances. Auto measurement compensation, constant motor temperature control, and semi-automatic balancing of the wheels, which I touched on before. These are only possible through ANCA's vertical alignment. So that's the servo drive part of it. We do the C-axis, filter-free jerk motion of the profile through the CNC, and once again, we design our own software. So ANCA's vertical integration, once again, allows us to control what we do. So what is a nanometer, which is what's made the Ultra possible? A standard machine has a resolution of 1/1000th of a millimetre. Seems very fine, but that was a control that we used to have over our linear machines and what our competitors have today. So if we command the machine, command the machine to move from point A to point B, we can see what happens here and here, but we can't see what happens in between. With nanometer resolution and ultra machines, we can control the movement and the drives of our machine down to 1/1,000,000th of a millimetre, which is, it's hard to believe. But what that did, it showed us where our problems were, where we needed to improve our machine, where we needed to fix our C-axis, where there was movements, vibrations, frequency errors. By having the nanometer control resolution, it's taken us to the next level. So what is a nanometer? A human hair is approximately 100 microns. A grain of salt, 60 microns. We start to lose visibility at about 40 microns. I'd probably a little bit more than that because I need glasses these days. I'm getting a bit old. But a red blood cell that people talk about so much in science, 7 to 8 microns. A dust particle, 2 to 5 microns. Bacteria, 1 to 2. The coronavirus that stopped the world, 0.5 micron. A standard machine, a standard resolution machine, and when I say standard resolution, is our linear machines and all of our competitor machines. ANCA is the only tool and cutter grinding company on the market today that has 1 nanometer resolution. So what is a nanometer? 0.001 of a micron. Try and understand that. One of my colleagues, he mentions, it's how fast your fingernail grows every second. It's amazing to have that control over a machine. Motor temperature control I touched on before. Motor temperature control, it's patented now in the US and pending other regions, but it actively maintains or controls the spindle of the temperature. temperature of the spindle. And the benefits are we can dramatically reduce our warm-up times. So when grinding, instead of starting the machine before you get started for an hour, getting all the temperatures level and consistent, motor temperature control gets us warmed up much faster, so we can start grinding faster, improving your production. Gives us better thermal stability, and it's consistent over the whole batch of the grind. Now, this is really important because if we go for lunch or we have an error where we have to stop the machine, temperatures fluctuate. So if we look at this graph with and without motor temperature control, the green graph here shows a standard warm-up cycle. So for example, we might grind for at least, warm up for at least an hour before we start to actually produce tools. And we can see the temperature fluctuation each tool we grind. So as we grind, we're doing heavy fluting operations which put forces through the spindle, heating up the spindle. Then when we come to do OD grinding, the temperature drops because we're not putting the forces through the spindle. So many factors have influence on the temperature of a machine. The RPM of the machine, the coolant in the machine, the coolant around the spindle jacket. Then when we finish grinding, the spindle stops and we start to lose that temperature again. So if we want to start grinding again, we have to go back through the warm-up cycle. So we're losing time, we're losing productivity. With MTC, we set and maintain a spindle temperature. So regardless of what we do, we maintain that peak. When we finish grinding, we maintain that temperature. So if we want to start again, we don't have to go through the warm-up process. It's money in your pocket. So why is the Ultra the best solution on the market? Let's have a look. We look at the surface finish of a tool on a ball nose. A ball nose is where it really shows up. And we look at a non-Ultra machine, the surface finish, and we look at an Ultra machine. We can see consistent grind marks come through with the Ultra, much finer variation or frequency through the tool, no waviness. So straight away with Ultra technology, we get the better surface finish. And that doesn't mean we have to use finer grit wheels to get these surface finishes as you would on a linear machine. With standard grit wheels using Ultra technology, we get these surface finishes. Process enhancement. So the effect on the torrid radius or wheel conditioning. So we look at a tool here before we condition the wheel. So I mentioned earlier how the grinding wheel is. So if we freshly dress a wheel and we start to grind, it normally takes about 20-30 tools for the wheel to settle down and become consistent. Because after a freshly dressed wheel, we have diamond still sticking up. With the Ultra technology, we're able to process and condition that wheel a lot earlier. Without the conditioned wheel, we get these marks between movements. With a conditioned wheel, straight away we start to get Ultra quality tools. Chisel area, that was another area where we needed to improve to make the perfect tool. With Ultra technology, we get much sharper forms, so much sharper lines, so the geometries are much better. So when the tool's in action, because the center of the tool, there's no cutting speed. So this area has to be perfect. And as I mentioned, consistency over a batch of tools. So from tool number 1 through to tool number 250, we guarantee to get the same results. Once again, it's only possible through ANCA's vertical alignment and Ultra technology. So the Ultra machine range, it started out a couple of years ago with the MX7 Ultra, was launched at IMTS 18 months, 2 years ago. And the MX7 Ultra is able to do diameter 32 down to 1 millimeter tools using Ultra technology, getting the high quality tools. It has a 38 kilowatt spindle and is really set up for high volume batch production. It's our big machine. It's our premier machine in the market. Recent released at EMO was the FX7. The FX7 is a more economical machine, so a lower cost machine, but now with Ultra technology is able to produce cutting tools down to 0.1 millimeters. So, a 2-flute ball nose, helical ball nose, down to 0.1 with those surface finishes and those accuracies. Only possible with Ultra. Recently released after EMO was the FX5 Ultra, going down to a smaller, less cost-effective, less price machine. Has a 2-wheel pack change, a 12 kilowatt spindle, 16 down to 0.1 millimetre, also only possible with Ultra. And launched this time at Grinding Hub, we have the Micro X. So it's a specific machine dedicated for micro tools, and it's able to do tools down to 30 microns. Ultras come with a 3-year warranty on parts and labour, and also 5-year warranty on linear motors. So that's part of the Ultra package. So today I want to also talk about what we're launching here at Grinding Hub. And this is our software. The software plays a very big part in our obviously day-to-day life. So here at Grinding Hub, we're going to launch RN35. So Toolroom is used on every one of our machines. It's the same software, whether it be the MX7, the FX5, or the Micro X, we use the same software. RN34 or RN35 is the latest version of Toolroom, so launching today. RN34 was designed around cutting tools in geometries, tool types. So to get those tool types, where RN35 is more focused around performance and productivity, so saving you money. RN35 has a better look and feel about it, new icons, it's a little bit more stylish, has a new user experience, so things are a little bit smoother, easier to understand. We have an improved, with RN35, it's around performance productivity. We have better simulation times and obviously improved grinding cycle times as well. Once again, shortening that time where your machine is earning your money, which is putting out more tools. Some of the enhancements of RN35, we have feed rate optimization and airtime reduction. So the airtime reduction is very important that we shorten, because this is when the machine's not producing anything, moving from here to here or moving from around a ball. That airtime needs to be reduced, and feed rate optimization is part of these enhancements. We have new SPC charts, so we can log and see what we're actually doing and record it. Simulation times are shortened. Profile fluting, so if we're doing a profile, we can actually get a constant hook angle around the profile. Can we go back? Yep. OD finish, multiple reliefs, is another feature or another enhancement. And of course, ball nose, corner radius, and user improved experience. So when I talked about shorter cycle times, just through simulation alone, on average between RN34 and RN35, we can expect on a typical tool up to 40% quicker simulation times. So it's quite an improvement, which means we can get grinding faster. If we take a standard program out of a machine today with RN34 and we put it into RN35, just straight away, without doing anything, we get approximately a 3% reduction in cycle time. But when we include feed rate optimization, we add another 10% onto that. So if we look at a standard cycle time of 7 minutes 30 in a RN34, we bring it into RN35 with feed rate optimization, we save almost 2 minutes just on a cycle time without touching anything. So RN35 is around performance productivity improvements. So if you want to experience the future of tool production, please come and see us at our booth at Hall 7A70, where we can see the Ultra in action. We actually have it grinding on the stand for Grinder of the Year. We have our Toolroom RN35, which we've launched today, And we also have AIMS and Auto Connect, which is an automated process of your machining. So thank you for your time. And yeah, if you're interested, please come and visit us at our hall.
Thank you so much. Awesome. Awesome presentation.
Thank you.
A lot of innovation in your presentation. I really. Are there any questions from the audience before I start here and tackle them? There's one. Let's get a micro.
Yep. Yep.
I was curious about the motor temperature control setup,
Yeah.
and how what's mechanically actually happening there to increase the thermal mass of the motor, or what are you doing to stabilize it?
So through the windings, through the windings of the motor, we're actually increasing the current, which sets a more constant temperature, so we can set the temperature where we want to, so that any other cycle or any other movement within the machine doesn't exceed that, so we can keep that constant.
I see. During the spindle off times, does that significantly increase the power consumption?
No, it doesn't, because the way it reads the temperature and adjusts to suit. So we have a tolerance band, so if it needs to, it's on or it's off. So it's not constantly on.
I see. Thank you.
I had exactly the same question, whether the power consumption will increase by having the same temperature.
As I said, it's more designed around making sure we can get grinding, between cycles. So we finish a batch and we put the next batch in. We don't have to worry about warming up again, especially when we're looking at the tolerances we are with Ultra. Standard linear machines, standard tools, you might be able to get away with some of that fluctuation, but for high quality tools, we want to make sure we maintain that tolerance.
Any more questions? I do have a question. You mentioned that the machine will recognize if there are any external disturbances and adapt, let's say, the wheels, etc. So is that something where, and then you said the new software is learning. Is that something where there's a machine learning in place? So it's kind of working predictively as well. So let's say I implement your machine. So after a while, it's not happening like recognizing and then adapting, but it's already adapted for the current circumstances.
So through the grinding wheel and the rotation of the grinding wheel, you'll get frequency and certain predictability with the frequency and vibration. So with the adaptive learning, it helps to compensate that much faster and can predict basically that frequency, what's coming out of that wheel. With the external disturbances, it's like if we put a force on an axis, it's how quick it responds. So for example, if I gave a 20 kilo bag of cement and I dropped it on your hands, it would be quick. But if I gradually placed weight on your hands, you can control it.
Absolutely.
And this is how the nanometer control and the nanometer resolution, the speed, the frequencies we have, are able to adapt to that. So once again, we feel that vibration come through, we're able to compensate.
Very good. You mentioned the high precision. That's something that was fascinating me, of course, as I'm not into the business, but really fascinating, the comparison with the blood cells, etc. But I mean, there needs to be a market for that, because on the one thing, you have that innovation, it's extraordinary. On the other side, you need customers that are having the need for that.
Correct.
Where's the need? What are the applications that need that high precision?
Well, there's people customers that don't believe they need it, but when you look at the ultra quality tools or the high quality tools, the time it saves you in not just grinding of the tool, getting the precision, where the end user might get when he's machining, he gets a better surface finish in his component. He doesn't have to do as much finishing or polishing work afterwards, so those tolerances and the profile accuracies come into play. But also with the better surface finishes, coatings stick better.
Okay.
Edge preparation, we get sharper cutting edges. We don't have to spend as long with edge preparation as well. So it's not just who needs it. The Ultra technology allows customers to benefit from these, saving them time, which means it's not just about the high quality cutting tool, it's also about saving time for the customer, putting money back into their pocket.
Yeah. That's the target. So I have plenty more questions, but unfortunately, as always, we're running out of time, especially about Tourum. I really like the connections between software and the machine, because it's great to see that you have the 40% improvement just by software. I mean, this is impressive. So good luck for ANCA.
Thank you.
One of the market leaders. So it was a pleasure to have you here, Darren, today.
Thank
Good
you.
luck for the fair. See you around, okay?
Thank you very much.
Thank you so much. Bye-bye. Big applause. Darren.